merge in between linked list. So let's get started. You are given two linked lists, list 1 and list 2, with sizes and a number respectively. Remove list 1's nodes from 8th node to the bth node and put the list 2 in their place. The blue edges and nodes are in the following figure. Indicate the result. Build the result list and return its head. Okay. I did take a look at this earlier because I was just curious, and it is a bit of a confusing problem, but I think I understand it now. But let's just write the inputs and outputs. Sorry. So inputs list 1, where that's a list node. Let's do this. Head of list 1. List 2 is a list node, head of list 2. A is the 8th node to start removal, and B is the bth node to end removal. So one question is, I'm gonna assume I would ask an interview, because since A is an integer, so I'm gonna assume every value in here is unique in the list, because otherwise indexing will be a nightmare because you don't know which. Oh wait, no. Oh, no, so this doesn't matter. No, so A and B are not the values. A and B are the index. So this is 0 index as well. Both are 0 index. Sorry about that. So one thing we can note is list 1. Can this be empty? And no. No. Same for list 2. No. This is guaranteed to have a length of 3, which is useful because A and B are within the indexes of the list, right? So some edge cases obviously for A and B I'm thinking of immediately is A can be the 0th. Oh no, A can start at 1. Starts at 1. Ends at the last index. Okay. They can be equal. A and B can be equal. So that's one thing to know. If that's the case, you just remove a node. But what I'm thinking about is, so we're guaranteed that A and B will be within the index. And we're guaranteed that these indexes are within list 1. I'm thinking output, I did not mention output, is return the head of the result list. I'm assuming this will be like probably the head of list 1, because list 1 will have, we're like inserting that list into list 1, so there's no need to rebuild it and make a new list. So logically, always in a list node thing, we need to have a dummy node that points to head. But it's kind of similar to like getting the ith node from the end of the list, in the sense that you take the difference of A and B, right? So in this example, A and B is, the difference is 1. So difference of 1 plus difference of them plus 1. So B minus A plus 1. Right. So that's the length that we need to remove. And we need to get to this index right here, right? So if we have a list of 10, 1, 13, 6, 9, 5, we need to go to, this is 0 index, 1 index, 2 index, 3 index, 4 index, 5 index, right? So we want to remove, well, since A is here is 3, B is 4, we want to get to index 2, right? And then if we have a difference of 2 right here, because difference is 2, we know that this is where like we need the list 2 to start from, right? 2 then should point to the list node right here, and then the end of this list should be the next value at this, right? So your I will be here, and j will be here, right? So I dot next will be list 1, and then the end of list will be j dot next. Okay, so logically what we need to do is take the diff, go to the a minus 1 index, right? So because we're guaranteed that a is 1, we'd go to, if for example the a was 1, we'd go to the 0th index, which is the first node, right? That's fine. You take the difference, you go to a of I minus 1 index, and you have a of I minus 1 node point to head of list 2, and then you have to traverse to last node in list 2. Take the diff, and then take the diff and advance. Advance j pointer to diff offset, right? And then go to a index 1 and move the j pointer along as well. And then you have a minus 1 node pointer, and traverse to the end of the list node, and then have list 2 end point to j dot next. That's pretty much it. All right, so let's do that. So diff is equal to b minus a plus 1. So dummy node is equal to list node of 0. Let's have a value negative 1, and next is head. Let's turn off this. Not head, sorry, head of list 1. And then so we have current equal diff, so current equal dummy. Let me so while diff is less than 0 or greater than equal to greater than 0, let me j node. So there's some weird noise happening inside this room, so I'm not sure if you can hear it, but okay, let's go. So j node, we're going j node on next, and then diff might equal 1. So I need to verify this is valid. Verify this. Sorry, it should be hashtag. Verify this is valid, but we'll assume this is valid. And so the j node is at the offset. So if this is offset 2, you would have current is equal to this, and it should be right here, right? So then, well, current index is equal, I think this could point to list 1, right? That's fine. So current index is 0, while current index is not equal to a minus 1. Sorry, I node is equal to list 1. I node is equal to I node dot next. J node is equal to j node dot next. And once that's the case, I node dot next is equal to list 2, right? So now we have this connection right here. We just remove this one, and then we need to do list 2 end is equal to list 2, and then while list 2 dot end dot next is not equal to none, is equal to list 2 dot end dot next. I am thinking this seems to be too trivial of a solution for a medium. There's no cool infrastructure, but this is the most like direct thing I can think of. But anyways, if this is the case, then list2 dot n dot next is equal to j node dot next, and then we return dummy node dot next. I'm gonna run this and see if this works. Oh, I am I am still writing in C. I am so sorry. I am still writing in C. I am very exhausted, so oh, I see. So obviously I am inherently doing a brute force on this, but and not bothering to. 13, 6, 9, 5. Oh, I'm not current index plus equals 1. Okay, that works. I just need to submit that, but okay, there you go. I just need to remember current, always I have the current index, increment that in a while loop, right? While to make sure that it can actually exit. And I guess this was right with that. What was this before? What was this? No, I was right on that. Sweet. With that, thanks for watching. See you tomorrow.